Okay, we're going to continue on with our three-dimensional geometry, and we're going to look at cylinders now. Cylinders are a lot like prisms in that you have two bases, but in this case the bases are circles. So cylinder has a circle for a base at either end. A soup can is a really good example. I'm not going to show you a soup can, but I'm going to show you a little spice can here. That is a good example of a cylinder. We can see that both bases, the top and the bottom, are circles. Now if you could imagine taking and just slitting open this label here and then laying it out flat, your lateral surface area, you know, the face of all of this, the lateral surface area, taking this and slitting it, laying out flat, actually comes out to be a rectangle. So that's going to impact how we calculate our lateral surface area. Okay, so we're going to be using the same formula for circumference as well as area of a circle, and then plugging them in as we need and where we need to do that. So I'm going to start with, we need to figure out our base area of the circle. So we're going to find the area of at least one circle, and we're going to use the formula, the two-dimensional formula for the area of a circle is pi r squared. When we plug that in, that would be 3.14. In this case, our radius is 5. So I'm going to plug in 5 squared. And when I plug that in, that's basically 25 times 3.14 gives us about 78.5. That's just for the area of that one circle. Okay. We're also going to be using circumference, because remember, if I take and slit this thing open and lay it out flat, the top edge of the rectangle that is the label is actually the circumference. If you remember, the formula for circumference is, we're going to use the formula where it said 2 pi r because we're given radius here. And so I'll plug that in, 2 times 3.14 times our radius of 5. That comes out to be 10 times the 3 point, which comes out to be 31.4. Okay, and that's going to be these edges right here. The top and the bottom is our circumference of this rectangle. The height, which is the height of our cylinder, is actually the other edge of our rectangle. So that's really going to impact as we move forward. Okay, so we're going to, first of all, just like before, we're going to start out finding the total base areas. And I said total because I have two of them. So I have base areas. So I have the top and the bottom circle, so 2 times the area of each of those circles, which we said was 78.5, which should give us about 157 units squared. Okay, that's our base areas. Now we need to find our lateral surface area. And that is going to be this rectangle right here. So it's 31.4 times 12, which is going to be equal to, I think, 377 units squared. Okay, and then our total surface area, I'm going to write that as TSA just to keep things moving, is the sum of those two things. So the sum of those two things is 534 units squared. Okay, and then our volume, again, I'm just going to abbreviate volume because I can't seem to write today. So remember, the volume is that capital letter base area times the three-dimensional height. Now if you remember, our base area is actually a circle. So we're going to be using that area there, 3.14 times 5 squared. I'm just going to put the formula in there. That was the area of a single circle, times the three-dimensional height, which we said was 12, which would give us an overall volume of 942 units cubed. We did that in a really short space there, but we're going to draw a line here, and we're going to draw another example of a cylinder. You're going to get a chance to do some drawing here. I'm going to draw this cylinder on its side. So try to draw an elongated oval like this. And then we're going to have an edge 2 edges, and then draw another curve here. And the only reason I'm having you guys do the drawing as well is I want you to connect here that our height actually connects our 2 bases and our 3-dimensional figures. And I think you just become more aware of that when you do the drawing yourself. So we're going to say our 3-dimensional height is equal to 8. Our radius of this figure is going to be equal to 6, right here. And we've got all that we need to continue on here. We're going to have to find the area of a circle. So I'm just going to write everything out so that you can see where you'd need to fill that in. Area of a circle, we're going to be using pi r squared. And that pi is 3.14 times our radius squared, which is 6 squared. And that should come out to be our area of 200, no, it'd actually be 113. 113 units squared. That's the area of one of these circles. So that's the area of just one of these. Okay, we're also going to be using the circumference of a circle. And that again is that 2 pi r. So we're going to plug in 2 times 3.14 times our radius of 6. And that should give us 37.68 for our circumference. So we need each of those things in order to continue on. So we're going to start with our base areas. So the base areas, again, we have 2 of these circles. We've got the front and the other side here. I shouldn't say the front, but the right and the left circles here. We've got 2 of those. We said 113. And that would give us 226 units squared. And then if we find our lateral surface area, that is going to be this circumference times the height. So that'd be 8 times the 37.68, which should get us to 301. And then when we do our total surface area, we're adding these 2 up. So we should get 527 units squared. Then our volume, again, we're going to be dealing with the base area, which is a circle, times the height. So our base area, one of these circles, the base area was 113. And we're going to multiply by the height. I guess I don't need to duplicate that notation there. The height is 8, and so that gives us a total of 904 units cubed.